Imagine standing at the edge of something so powerful, not even light can escape. A place where time stops, space tears, and the laws of physics completely break down. In my viral trilogy, we explored what happens if you fall into a black hole. Oh, this is the complete black hole guide, everything you need to know, all in one place. Let's dive in. But we've got 8 chapters ahead, so grab a snack, hit subscribe, and let's explore the most extreme objects in the universe. Let's start with the basics. A black hole isn't actually a hole, it's the opposite. It's the densest thing in the universe. Imagine crushing Earth down to the size of a marble. That's density. Now imagine crushing an entire star, something 1,000,000 times heavier than Earth, down to a single point. That's a black hole. But here's what makes them special. Their gravity is so intense, they literally rip a hole in the fabric of space-time. Nothing, not even light moving at 300,000 kilometers per second, can escape once it crosses a boundary called the event horizon. Cross that line, and you're gone, forever. That's why they're black. We can't see them directly. We only see their effects on everything around them. So how do these cosmic monsters form? It starts with a star. Not just any star, a massive one, at least 20 times heavier than our sun. For millions of years, the star burns hydrogen, creating outward pressure that fights against gravity's inward pull. It's a cosmic tug of war, but eventually, the star runs out of fuel. When that happens, gravity wins. The star's core collapses in less than a second, one of the fastest, most violent events in nature. The outer layers explode in a supernova, visible from galaxies away. But the core, it keeps collapsing and collapsing and collapsing until it becomes so dense, it punches through space-time itself. A black hole is born, the entire star's mass compressed into a region smaller than a city. That's a black hole. Not all black holes are created equal. There are actually 3 main types, and the differences are insane. First, stellar black holes. These form from dead stars, and they're small, only 10 to 100 times the mass of our sun. But don't let that fool you. Get within a few kilometers, and you're done. Then we have supermassive black holes. These are the monsters, millions to billions of times the sun's mass. And here's the crazy part, there's one at the center of every major galaxy, including ours. The one at our galaxy's center, Sagittarius, a star, is 4 million times the sun's mass. Right now, it's relatively quiet, but when it feeds on nearby stars, the entire galaxy knows. Finally, intermediate black holes, the mysterious middle children, hundreds to thousands of solar masses. We've only recently confirmed they exist, and we're still figuring out how they form. Some scientists think they're the seeds that grow into supermassive black holes. Others think they form when stellar black holes collide. The truth? We don't know yet. Alright, now the fun part. What actually happens to your body if you fall in? This is where the original trilogy started, but let's add more detail. As you approach, you'd notice something weird. You're falling faster and faster, but time itself is slowing down. To an outside observer, you'd appear to freeze at the event horizon, stuck there forever like a cosmic statue. But from your perspective, you cross in seconds, and that's when things get horrific. Gravity at your feet is pulling millions of times harder than at your head. Your body stretches. First, you'd feel like you're on a medieval rack. Then your bones would snap. Then your molecules would separate. Finally, your atoms themselves would be ripped apart. Scientists call this spaghettification, but that's way too cute for what's actually happening. You're being atomized by tidal forces, the difference in gravity across your body. Here's the weird part. In a small black hole, this happens before you cross the event horizon. But in a supermassive black hole, you'd cross the horizon completely intact. You wouldn't even notice until it's too late. Now let's talk about the view, because it's arguably more insane than the death itself. First, you'd see gravitational lensing, light bending around the black hole's massive gravity. Stars would appear in impossible positions. You'd see objects behind you, beside you, and in front of you all at the same time. Your field of vision would warp into a sphere. The entire visible universe would compress into a shrinking circle behind you. Then you'd see the photon ring, light trapped in orbit around the black hole. It would look like a ring of fire, photons that have been circling for potentially thousands of years. But here's where it gets truly mind-bending. Because of time dilation, you'd watch the universe age and fast forward. Stars would be born, live their entire lives, and die in what seems like seconds to you. Billions of years of cosmic history would flash before your eyes. Finally, light waves would compress as you accelerate. Everything would shift blue, then ultraviolet, then into radiation wavelengths you can't see. The universe would either fade to black or explode in a blinding flash of gamma rays that would kill you instantly. This is the question everyone asks. Could you actually survive? And the answer is, maybe, under very specific, theoretical conditions. Not all black holes are the same. Some rotate, they're called Kerr black holes, and rotation changes everything. A rotating black hole has two event horizons, an outer one and an inner one. Between them is a region where, theoretically, you might avoid the singularity entirely. Some physicists believe the center of a rotating black hole might be a wormhole, a tunnel connecting to another region of spacetime, maybe another universe. Maybe another point in our universe. We don't know, but here's the catch. First, you'd need a supermassive black hole, or you'd be spaghettified. Second, the wormhole would be unstable, collapsing in microseconds. Third, you'd need to travel faster than light to make it through. Fourth, the radiation inside would vaporize you. So technically possible? Yes. Actually survivable? Almost certainly not. You'd need technology we can't even imagine yet. So what's actually at the center of a black hole? This is where physics breaks. At the very center is something called a singularity, a point of infinite density and zero volume. Every equation we have produces infinity or undefined when calculating what happens there. That's a problem. In physics, infinity usually means we're missing something. Our theories, even Einstein's general relativity, completely break down. Some scientists think quantum mechanics holds the answer. Maybe the singularity isn't a point, maybe it's a region where space and time themselves are quantized, broken into discrete chunks. Others think string theory reveals extra dimensions hidden inside. The truth? Nobody knows. To understand what's inside, we'd need a theory of quantum gravity, something that unifies quantum mechanics with general relativity. We don't have that yet. And there's another mystery, the information paradox. If black holes destroy information, they violate fundamental laws of physics. Stephen Hawking spent decades trying to solve this. His conclusion? Maybe information isn't destroyed, maybe it's encoded on the event horizon, or maybe it escapes through Hawking radiation. But even he wasn't 100% sure. It's one of the biggest unsolved problems in physics. Finally, let's talk about the future. Because black holes might be the last objects in the universe. Stephen Hawking discovered that black holes aren't completely black. They emit radiation, Hawking radiation, and slowly evaporate over trillions of years. A stellar black hole would take 10 to the power of 67 years to evaporate. That's a 1 with 67 zeros after it. The supermassive ones? 10 to the power of 100 years. By comparison, the universe is only 14 billion years old. In the far, far future, after all the stars have died, after all the galaxies have drifted apart, after even protons have decayed, only black holes will remain. They'll be the last light sources in the universe, glowing faintly from Hawking radiation. And then, one by one, they'll evaporate too. The last black hole will disappear, and the universe will enter true heat death, a cold, dark, empty void where nothing can ever happen again. Unless there's something we don't understand yet. Maybe black holes birth new universes. Maybe they're portals we haven't figured out how to use. Maybe they're trying to tell us something about reality itself. Black holes are the universe's greatest mystery. They break our physics, challenge our understanding, and force us to confront how little we really know. We've covered what they are, how they form, what happens if you fall in, and what might be inside. But honestly, we're just scratching the surface. There are still so many questions. So here's my question for you. What black hole topic should I cover next? Colliding black holes? The photo we took of M87? How we could use them for energy? Drop your answer in the comments. If this video blew your mind, hit subscribe. I break down the universe's biggest mysteries every week. Thanks for watching, and remember, stay curious. Oh, and if you haven't seen the original trilogy that started this all, it's linked right here. Trust me, it's worth it.